Hello, everyone. My name is Laura Delgado Lopez, and I'm with the Institute for Global Environmental Strategies. We are celebrating Earth Science Week today, and we are talking with Earth scientist and former astronaut Piers Sellers. Hi, Piers. How are you?
Great. How are you doing?
Excellent. So as I told you before, we're celebrating Earth Science Week, and the theme for this year is mapping our world. And as you know, NASA is mapping changes taking place in the environment, mapping our interaction with the environment and everything in between. What would you say are some of the key things about our planet that we need to continue understanding better?
Okay, well, there's a whole lot of things that are changing pretty rapidly. They're changing for a number of different reasons. One is the kind of direct impacts that humans have on the Earth's surface, like whenever we go and clear a forest out to make agriculture, whenever we, expand a city. These are direct changes that we can see basically from space. We map them exactly like anybody would do at school. And there's other stuff, though, that is harder to quantify that is also changing. And that's things like the extent of the polar ice cap, how big it is in winter and how small it gets at the maximum summer melt, things like that. So we're trying to basically put numbers to these things that are changing due to climate change and direct human impacts.
I mean, it's useful for all of us that are not scientists to see the maps to kind of get a quick and idea of how things are changing. But how important are they in your work?
The scientists are no different from anybody else. I mean, we all see the world as maps, right? Ever since we started at school as kids, there's a map. And I think that's the way people are trained to visualize how things look and how they change and the rate of change. So a lot of the tools we've developed are just smart maps. They're just different ways of looking at information on the surface of the Earth or in the atmosphere that changes through time. We use all kind of really nice tools just to make cleverer, more understandable maps. But they're still maps.
And you use them to communicate those results as well.
Yes, very powerful. I don't know if you remember the ozone hole story. There was a few, back in the 90s and the early noughties, the business of how the ozone hole was getting bigger and bigger every spring down there in Antarctica. You could talk yourself blue in the face about how this was happening. But the thing that the public and politicians immediately understand is this time series of maps showing how the hole got bigger and bigger over time. A kid could understand it. So they're very, very powerful tools for communication, I think.
Excellent. Yeah. So in addition to using maps to communicate, we're also this week introducing students to a lot of NASA tools that allow them to download data and manipulate it and use it to develop their own maps. Now, that seems a little scary for some, but why do you think they should take this challenge?
Oh, this is the way to basically make the best use of the rest of your life, to try and develop the tools and software to take all these, gazillion points of data and map it out in a clear way. That's taken some very smart people many, many years of effort to make something that's quite difficult and time-consuming simple and straightforward. So I would advise anybody who's getting into the business, get friendly with the tools. They will save you years of your life and give you a reliable result.
In addition to being a lot of fun.
Yes, and you get there quicker. That's the main thing is, we all want to get the result quicker, right?
Yeah.
And see how well we're doing. So, yeah, I would strongly encourage young people who are getting into business, sit down with some of the old hands. Learn how it's done.
Thinking back about the work you have done as an Earth scientist, your career began back in the 80s, and you came to NASA to design global climate models that would capture the interactions with the biosphere. Can you talk to us a little bit about what that means and how much has that research improved in the last 30 years?
Oh, well, when I started out in this area, it was a brand new area. And a tremendous fun to, be making discoveries. So we found out that basically the Earth's climate over the continents is highly dependent on the vegetation that's there. Vegetation, in order to do photosynthesis to grow, it sucks water out of the ground and releases it into the atmosphere. And that's what sort of feeds the clouds over the continents and actually feeds the water cycle over many of the continents. So the climate over the continents is in large part dependent on the life living on the surface. If the whole world was a desert, like a parking lot, you'd see very little evaporation over the continents and very little rainfall in the continental interiors. So life kind of helps generate the system that keeps life going. It's kind of interesting.
And so we can model those interactions.
Yes, yeah. You can actually reduce the whole business of how a plant works, how it grows, and how it extracts resources to a set of equations. You
Okay.
can put them in a computer model of the climate, and you have the vegetation and the climate talking to each other, and you can actually see these interactions. And then when you think you understand it, you go out to the field and take a few measurements and prove yourself completely wrong, and then go and improve the model and do it again. So we spent many years doing that, and over the last 25 years, we've really made enormous progress, and the models now mimic nature very well. And that'll help us predict future climate much better.
Much better. Excellent.
Mm-hmm.
And I also know that in your early career, you also worked in the Terra mission. And since then, you know, NASA has launched an amazing suite of satellites that just look at almost every aspect of the system. Did you know back then that we would have so many different ways to explore the planet?
It was the hope. You know, it was kind of a dream. Terra was the very first Earth observing system mission, which was tasked with the business of understanding the Earth system. You know, it was an intellectual concept that we wanted to get these data, these new observations from space, improve the models, and move forward and do better in terms of prediction. So Terra was the very first platform. I was a project scientist for it. Christopher Scalise was the project manager back then, and now he's the center director at Goddard, so he's done well. But since then, you know, there's been a host of other platforms. After Terra came Aqua, then Aura, then a whole bunch of other satellites, and they've done a tremendous job in teaching us about the planet, and we have learned so much.
And so we were talking before about models, when we were talking about the biosphere. What is the link between satellites and satellite data to those kinds of models?
Well, there's some things that I think are just about impossible to do for people like you and me on the surface. Okay, I'll give you a couple of examples. In our biosphere model that's embedded in the climate model, we have to be able to see or check where the vegetation is and what it's doing month by month. Now, you know, you would need 1 million biologists to run around the world counting all the leaves and taking measurements to do, you know, a really bad job of that. As it is with a satellite, you know, it just goes around there. It sees the whole world at once. It gets all the data in a day or so for the whole world. And you have a picture of what the whole world's vegetation is doing. The same thing with ice. I mean, good luck trying to get measurements of the ice on the polar ice cap, okay, during winter. You know, that you'd have to be a hero to go do that and have a lot of husky dogs and all the rest of it. But you can see it from space. And you can really get precise measurements of the extent of the ice and how it's changing from space. You don't have to go out there and do it. Thank goodness.
And at the same time, it's not just satellites. What you were just talking about reminded me of NASA's Operation Icebridge mission. And so that's an airborne campaign. And of course, NASA has several airborne campaigns. There's also, like you talked about, ground observations. Why can't we just let the satellites do all the work if they're so much better?
Well, there's a whole science between what a satellite sees through its little lens or antenna and what's actually happening at the surface. So we do a number of things to check on how well we're doing or how well we think we're doing. So let's see, we're trying to measure something like ice extent from a satellite. What is really happening on the surface that gives us the signal in orbit and helps us, you know, see what is actually really working? Well, we can send a person down onto the ice and they could take samples, and we do that. We send aircraft that fly instruments at low altitudes. You can really see all the structure and stuff, and we do that. And we send very high-flying aircraft, spy planes basically, that fly around almost above all of the atmosphere to almost see what a satellite's doing. And when you do all these checks, you can really narrow down the uncertainties about the satellite measurement, and then you know what you are measuring from space.
So it's the combination of all the different sources.
Lots of checks and balances to make sure that you're not lying to yourself. That's right. Always. You know, trust but verify.
Excellent. Yes. And so NASA does work in all of those areas. That's very interesting. And thinking about the different perspectives, let's talk a little bit about your career as an astronaut. How would you describe your first impression on seeing the planet from orbit?
Well, the first seeing the planet from orbit through a window was mind-boggling and beautiful, sort of zooming along at 5 miles per second over this shining blue planet. But actually getting out of the spacecraft and doing a spacewalk, instead of looking through a little porthole into the aquarium, you are in the aquarium. You're swimming around out there in space, looking at the world below you and seeing it as a huge, big blue ball. Just beautiful. So, just like everybody else who's been in space, I was really impressed and moved at how beautiful our planet is. I'd like to, everyone I know, I'd like to take them with me to show them that it's just such a beautiful sight.
We would love to go.
Yes.
So get on that.
Or my invite list. There you go.
Now, was there anything you saw when you had time? Because I know you were working out there. But when you had time, is there anything?
Working very, very hard. That's right.
Did you see anything that kind of inspired new questions, new Earth science questions that perhaps when you were back on Earth you wanted to explore?
I saw several things that made an impression on me as a scientist. I kind of knew what things like large structures in the atmosphere would look like, hurricanes and fronts, but to really see it with my own eyes, because you can see 1,000 miles in each direction when you're in space.
Oh. See
1,000 miles that way, see 1,000 miles that way. So you could see, big piece of real estate. So to see a hurricane below you, like a huge cartwheel, just down there, doesn't seem to be moving because, you're going over it very fast and it's not moving very fast. Mm-hmm. It was impressive to see these structures with your own eyeballs as opposed to a photograph or something. The other thing that impressed me was how thin the atmosphere is. So you've got this huge planet and this tiny thin layer of blue around it. And that's everything that we breathe and live in. It's very, very thin. It's like an onion skin.
So that gets at why some astronauts in the past have talked about just being impressed with the frailty of the Earth system?
No question about it. The atmosphere, that we rely on, and for life, is a very, very thin, finite volume of gas. So it's easily affected by things we do. That's kind of obvious. Just looking at the oceans too. There's not much of that. It's just a thin layer of water here and there on the planet. So the bit of the biosphere that we enjoy is a very thin kind of shell around this large planet. Okay.
Now, did you take a lot of pictures? I know there's the astronaut photography database. It's over 1.6 million photographs.
Wow.
Did you take a lot of them?
I didn't take a large fraction of the 1.6 million. I took a few. I have some favorites. I took some photos of basically favorite places on the planet that I had visited or worked in and all the rest of it. But some of my favorite pictures are just, general views of the world, cloudscapes, sun coming up over the Earth, seeing the curvature of the Earth, and seeing people work in space. That's always, seeing people work in a totally alien environment. That's always beautiful.
And that makes me ask about that photograph behind you.
That's right. That's actually me on my second mission, hanging out during a space.
Hanging out in orbit.
Yeah, the weather was great. And my friend Mike Fossum, I didn't take it, see. My friend Mike Fossum said, "Hey, Piers." So I looked up, waved, and he took this great picture with a world behind me.
Yes, so, you were busy working.
I was busy working. I had time to wave. That was about it.
So last year for our Science Week, we wanted to highlight the very many different career paths that can take you to become a NASA Earth Explorer, everything from engineering and science all the way to art. In your current role, you help manage Earth and space science for the NASA Goddard Center. What is that like? Can you walk us through a typical day?
Well, since I've joined the wonderful world of management, science management here at Goddard, I'm finding that the typical day is full of non-typical things, all kinds of different things every day. But basically, what is the job? The job is to help 2,500 people do their science, remove obstacles, get them what they need, get the equipment they need, get the permissions they need, lab space and things like that. And particularly for our young scientists just starting out, they need a lot of help getting access to the resources they need to do their jobs. And that's my job. It's
Great.
Fun. I learn something new every day talking to all these scientists, particularly the youngsters. They're full of new ideas, excited to be here. It's great. So every day is like a feast.
So have you discovered new subjects and perhaps connections between planetary and Earth science research?
Well, those links were kind of always there. I'm just rediscovering them for myself. It turns out that the people who work on instruments, detectors, remote sensing techniques, a lot of them are quite just as happy exploring Mars as they are doing Earth observations. A lot of the same technology and methods are used. So this community, you know, they're pretty versatile. They go backwards and forwards. They'll be studying the planets. They'll be studying Earth. They'll be looking at the stars, looking for exoplanets. Very exciting. That's planets around other stars. So, you know, lots to keep people busy here.
Yeah, there's no shortage of exciting topics.
No, none at all. I'm seldom bored. How about that?
So have you discovered a second favorite planet?
A second favorite planet? I was being told by a young postdoc the other day about this planet that's going around a red star. Mm-hmm. And we think it's a water planet. It's probably twice the size of Earth, okay, with a deep ocean, with likely a deep ocean. And so the force of gravity on this bigger planet is about 4G. So you know, it'd be very hard for you to stand up there. But if you were floating in the water, you wouldn't care. So you could be quite happy as a fish or a whale on this planet, maybe. So I bet you there's all kinds of different worlds out there that, you know, future generations will discover with all different kinds of life on there. I can only imagine.
That are just different enough from Earth.
They'll probably all be a bit different from Earth. I don't think we'll find anybody looking like you, or hopefully not looking like me, on any of these other places. You know, seriously, I think that life will evolve in different ways in different environments, and you know, Darwin will take over, and every life form will be a little bit different.
And that's one of the big questions that NASA research is helping us answer. Just, is there life out there, and can we find it?
Well, one of the answers is already in. You know, when I was a young scientist, there was debate about whether there were planets around other stars. Well, now we have 800 confirmed planets and 3,000 candidates, and they just come in every day.
Yes.
As our techniques get better. So question one has been answered. There's planets all over the place. Now, the next thing is, how many of those have water and atmospheres? And then one day, we have to make telescopes. There'll have to be big telescopes sitting in orbit that can actually look at the atmospheres of these exoplanets and see what's in them and look for traces of life. So I hope to see that before I actually fall off my perch. Yeah.
Yes, we all do.
Yeah, that would be something.
Are you getting to do any research, or I know that the management aspect of your job takes up a lot of time?
Right now, no, not at all. I'm basically, because I'm learning the ropes as a manager, and it takes a lot of time and thought. But I have a few pet projects I'd love to get back to in due course. I think I'd like to demote myself to being a new postdoc and start again.
Well, that's,
get re-educated and do it again.
That's the exciting part.
It's a lot of fun, yeah.
So you can certainly urge the students watching to get into Earth science and study all of these different mysteries about the planet.
I would say there's plenty to do. Since I'm an Earth scientist, I'll do a special shout out for Earth science, right? The science of Earth science is really good, interesting stuff. It's intellectually fabulous, but it's also very, very important.
Yes.
You know, understanding our Earth is a nice thing to do. You know, it's good science, but it's really important for the future of, you know, the 7 billion, soon to be 10 billion people living on this planet. So as an Earth scientist, you're really helping.
Yes. And so we certainly hope that there's more and more Earth scientists out there.
Yes. Go Earth scientists.
Yes. And on that note, thank you again, Piers. And to everyone watching, please follow us on social media at NASA Earth Science Week, and go to climate.nasa.gov/ESW 2013 to get the latest updates and continue celebrating the study of our planet. Thank you.
Thank you.